Today we are going to talk about Newton's laws of motion. If you have not watched the video that I uploaded to Google Classroom, you need to do that before you watch this PowerPoint presentation. The link is here on the PowerPoint. I don't know if you can click it through this or not. Or like I said, I uploaded it to Google Classroom, so please make sure you do that first. Newton's first law says an object at rest stays at rest, and an object in motion stays in motion unless acted upon by another force. What that means is basically something that's in motion is going to stay at motion unless something stops it. And an object at rest, it's not going to move unless something pushes it or another force acts upon it. The object will keep moving in the same speed, same direction until some force changes it. This is also called inertia, which we're going to discuss on the next slide. What inertia is a tendency to resist changes in motion. The video went over this when they showed the differences in trying to push a big couch versus a small stone. Inertia depends on the mass of the object. More mass equals more inertia. Less mass equals less inertia. What this picture illustrates is the truck had brakes, but there was nothing holding that stone. So when the truck stopped, the stone kept going until it was acted upon by a force, which was the truck cab, to stop it. Newton's second law relates force, mass, and acceleration. The acceleration of an object is directly related to the total force acting on it. I'm going to show you a formula here in a second. They also showed you that formula in the video. If the force goes up, the acceleration also goes up. If the force goes down, the acceleration also goes down. That's called a direct relationship. One thing goes up, the other thing goes up. That's direct. The formula for this is F equals m times a, which is mass times acceleration. Please pause the video and copy down Newton's second law triangle right now. The label for force is newtons, which is abbreviated capital N. The label on mass is kilograms, and the label on acceleration is meters per second squared. Newton's third law describes action and reaction pairs. For every action, there is an equal and opposite reaction. In the video, they showed this with the tennis ball bouncing. The same force that the tennis ball hit the floor with, it comes off the floor with that exact same reactional force. A book doesn't fall through the table because as it pushes down on that table, the table also pushes up on it to keep it in place. If there's a balanced force, there's no movement. So I want you to think about two equal teams on tug of war. If they're both pulling, both equal strength, that flag in the middle won't move. An unbalanced force is if you have a bunch of guys versus probably a bunch of girls. The guys are pretty easily going to pull the girls over the line. That would be an unbalanced force. So like I said earlier, force is measured in newtons. And just to remind you, mass is always in kilograms. Acceleration is always in meters per second squared. So if you did not label that triangle when I went over the labels earlier, go ahead and do so now. And this explains how they get a newton for the force unit. Really, it means kilograms times meters per second squared equals a newton. I just need you to know that force is measured in newtons. The term gravity is the force of attraction between two pieces of matter due to their masses. Every object is generally attracted to every other object. The amount of attraction just depends on the mass or the size of the object. So we stay planted on Earth because Earth's mass is so much bigger than our mass that gravity holds us in place to Earth. Whereas compared to each other, we don't really stick to each other because our masses are so similar that we can overcome that force of gravity. As far as free fall, this is when I would take maybe a marker or any other object and just drop it, like if we were to drop things out my window. This is when gravity is the only force acting on an object and it's directed towards the center of the earth. And we'll actually do a free fall lab when I'm able to come back. In the absence of air resistance, everything falls towards Earth at the same rate. This is called gravity. Earth's gravity is 9.8 meters per second squared. Highlight, underline, circle 9.8 meters per second squared. You must know that number. I'm not going to give it to you on a test. You have to know that gravity equals 9.8 meters per second squared. Weight is a gravitational force acting on objects. When we step on a scale, we are actually measuring our mass plus how hard gravity pulls on our mass. So the formula that you see there, weight equals mass times gravity. Weight is measured in newtons, mass is in kilograms, and gravity, you now know the number for, is 9.8 meters per second squared. This goes into kind of what I just talked about with mass versus weight. So the question is, do you weigh differently on Earth than you do on the moon? Take a second and think about that. If you answered yes, that would be correct because there's much less gravitational force on the moon than there is here on Earth. Free falling object, the acceleration is the same as gravity, which is 9.8 meters per second squared. And the velocity of a free falling object, a couple different formulas, but they mean the exact same thing. The G and the A are the same thing. Velocity equals gravity or acceleration, G or A, times time. And you see the triangle here. Take a second and write this in your notes. Velocity is measured in meters per second, time is measured in seconds, and gravity is measured in meters per second squared. If you didn't make yourself a weight triangle, you should go back to a couple slides and use that information to make yourself a weight triangle. So the problem here says an object starts at rest and falls under the force of gravity. Your equation is V equals G over T. I lied. V equals G times T. And we're looking for the velocity at the end of 4 seconds. As we plug in numbers, G is always 9.8, and they gave you the time in the problem, which is 4 seconds. So the velocity equals 39.2 meters per second squared. Same problem, now using the distance formula, which you should write down somewhere, and you see that right here on the screen. Distance equals acceleration times time squared. You always want to square the time first, divided by 2. So as we start plugging in some numbers, remember A and G are the same thing. They're both gravity. You would plug in 9.8 times 4 squared divided by 2. I always tell kids you should square that 4 first, press equals, then take it times 9.8, press equals, then divide by 2, press equals one more time. Otherwise, sometimes the calculator does funky things. I would just break it down into those 3 steps. So eventually you get 156.8 divided by 2, and D is going to be 78.4 meters. You were looking for a distance, so the abbreviation or the label would be meters. Terminal velocity is as an object falls through the air, at some point the air resistance meets how fast it's falling down. So this is the fastest something can fall. At this time, forces are balanced and no further acceleration will take place. Object will still be falling very fast, but will not be increasing its speed. There'll no longer be acceleration. Generally, for a free falling object, terminal velocity is about 320 kilometers per hour or 200 miles per hour. What you will be doing now is, if you did not finish the math from yesterday, I need you to finish that before Friday. Plans have changed slightly since yesterday. It will not be back until Friday, hopefully. And then you should get the Chapter 3 crossword, and that is what I would like you to work on for today. So hopefully these video lectures are working and they're going grand, and I will be back in the classroom as soon as I can.